Good afternoon, one and all. I am R.V. Kiran, Assistant Professor, Department of Mechanical Engineering. Today, in this video lecture, I am going to explain the second part of the electrical and electronic comparators, which is the last type of the comparators. So, in the earlier classes, we have discussed about the types of mechanical comparators, that is the dial gauge, Johnson microcrater, Reed type comparator, and the sigma comparator. And we have also discussed about the optical type, that is the G's ultra and D's operators, and the pneumatic comparators. And in the last video lecture, we have discussed about the first part of the electrical and electronic comparators. And in this video lecture, we are going to finish this topic, that is the electrical and electronic comparators. So we have seen the electrical comparator. So this is the plunger, which is used to measure the workpiece, and it has two attachments to the surface of the plunger, and to the plunger there is two thin steel strips. So these are the two thin steel strips which is fixed to the galvanometer. So to the steel strips there becomes the armature here. So it has an armature at the center of the position, and the two other positions it has two blocks which is attached to the galvanometer. So this is the galvanometer which is fixed to the blocks of the thin steel strips. So whenever there is deflection in this plunger, it moves in the upward direction, and these are going to touch the armature strip, and this armature strip is used to vibrate in its motion, which is used to touch the surface of the blocks, and these blocks are to be vibrated with the motion of the armature. So whenever the vibration comes, and this is turned to a signal, so this is converted to the signals. So these are the working existed in the electrical comparator. So here the plunger is the sensing element, and the movement of the displacement of an armature inside a pair of coils. So these are the two pairs of coils. So these are the two pairs of coils which is used to be vibrated with the displacement of an armature. So this is displaced with the help of the displacement of the armature by the steel strips, and movement of the armature causes change in the inductance in these two coils, which is resulting in a net change in the inductance. So this changes in the inductance. So this changes an imbalance in the bridge circuit. So the bridge circuit means the Wheatstone bridge circuit. It consists of 4 points. So this results in the input breaking of the input. So that output displays the display device, that is the analog or digital, which is calibrated to show the readings in the units of the length. So this shows the calibrated readings of the linear displacement. So we have seen the different advantages and disadvantages. So measuring units can be removed from indicating the units. So this can be taken as the independent units also. And variable sensitivity which can be adjusted as per the requirement. So there is a variable sensitivity which can be adjusted as per the requirement, and there is no moving parts in these comparator. So that is the main advantage of these comparators. So there is no moving parts, hence it can retain accuracy over longer periods. So longer period for the longer periods of points, you can retain accuracy with these type of comparators. And higher magnification is possible as compared to mechanical comparators. So the magnification which is possible to the mechanical comparators is very high. So you all know about the magnification of a measuring instrument. So generally, what is meant by a magnified object or magnification device? So magnification means the accuracy which we are going to take with an instrument. and higher compact sizes of the probes are available. So compact sizes of the probe arcs are still available in this type of comparators. And coming to the disadvantages, the accuracy of working of these comparators is to be affected due to temperature. So due to the temperature, the working of these comparators is to be affected, which is due to the humidity and temperature. It is not a self-contained unit. It needs stabilized power supply for its operations. So generally AC current is used, that is, it is used in the Wheatstone bridge of AC unit, that is AC Wheatstone bridge. Next, heating of coils can cause zero drifts and may alternate calibration. So it may changes the calibration of the measurement. So that is the heating of coils. Next, it is more expensive than the mechanical type comparator. So generally these electrical comparators are more expensive than the mechanical comparators. These are the advantages and disadvantages which we have seen in the electrical comparator. So next, another type of instrument is the working for the electrical comparators is LVDT. So we have already defined in the earlier class, that is linear variable differential transformer. So the main components of the LVDT are a transformer and a core. So the transformer consists of three coils, a primary and the two secondaries, which is mounted on a hollow cylindrical tube. And the primary coils is located between the two secondary coils. So generally these primary coils are located in between the two secondary coils, and the ferromagnetic force moves freely inside the cylinder. So this ferromagnetic force is moving very freely inside the cylindrical tube, and non-ferromagnetic shaft or push rod, which is coupled to the core, are connected to the object being measured. So these are going to be connected with the object being measured. So this is the LVDT. So this is the electromechanical transducer which converts the rectilinear motion of an object to the electrical signal. So the maroon color ones are the secondary windings, and the blue color which is in between the those two secondary windings is called as primary winding section, and there is a movable core which is attached to the for the displacement. So whenever we are going to move it, that is for the user for the displacement. And this electromagnetic transducer has the lead wires in the one side of the displacement of movable core, which it has this primary winding and the secondary winding. So generally, this LVDT works on the principle of the conversion of the measuring contact is converted to an electrical signal. So this is converted to an electrical signal. And the electrical signal is recorded by an instrument here. So this is recorded by an instrument which can be calibrated in terms of the plunger movement. So this is recorded by an instrument which is can be calibrated in plunger movement. So for this, an AC Wheatstone bridge circuit is used with a galvanometer. So this is used with a galvanometer, and it can be rather be said that the electrical comparator works on the principle of Wheatstone bridge. And these electrical comparators have no moving parts. Thus, a high degree of reliability is expected from these instruments. So, a higher degree of reliability is more to be expected from these instruments. So these electrical comparators convert the linear movement of the plunger into the electrical signals, and these signals rely on the Wheatstone bridge provided for the measurement. So Next one is the electronic comparator. So this is the line diagram which we have rarely in the net or any other type. So in the textbook also they will give it. So I have taken it from some other purpose. This is the electronic comparator. So in these type of electronic comparators, it consists of the transducer and an oscillator which is oscillated, and next one is the amplifier and the demodulator, and last one is the direct current which is fixed to the meter. So first of all, we see the gaps between these oscillator and amplifier. So in between the oscillator and the amplifier, small AC type signal is used to forward the motion, and from the amplifier to demodulator it has a large AC signal, that is alternating current signal, and after the demodulator it goes to the meter which is seen in the digital curve of the signal. It has a direct current, it uses the direct current type. So first of all, the readings has been taken to the transducer, that is from the transducer, and then it is sent to the oscillator. So the oscillator takes the readings which is have been reading from the transducer end. So then it is sent to the oscillator, and from the oscillator it is then sent to the amplifier which amplitudes the errors, and through a small AC signal. So that it is sent to the small AC signal. So then from the amplifier it then gets to the demodulator, in which the waves has been demodulated and sends to the verification of the element. So that is, it is sends directly to the direct current. The next one, this electronic comparator is more complex and which have an advances in the integrated circuits, which is having reduced in size and power consumption of the equipment. So this power consumption is very reduced, can be reduced by the other elements. So to reduce the power consumption, we need to reduce the electronic compassion of these elements. And these electronic gates are more accurate and more reliable than the others one. So compared to the other type of mechanical comparators, these are more accurate and reliable. And most significant advantage is the speed of response. So speed of response means the amount of measurement we can take in the less mean time. So lesser in the lesser time, what are the readings you have been taken in the less type of time. So the measurement rate of 500 per minute is easily accomplished by an electronic comparator. So 500 readings per minute can be taken with the help of this comparator. So that is very, very high one. This makes the instrument a dynamic measurement. So this makes the instrument a dynamic instrument for the measurement. So that is why electronic comparators are highly using than the other comparators. So they are used for the higher accuracy and higher measurement rate. So next one is the advantages. So what are the different types of advantages for the electronic comparator? First one is the higher accuracy and reliability. So these electronics comparators have higher accuracy and high reliability in position. Next one is the high sensitivity in all ranges. So in all type of temperature ranges, it have high sensitivity. And next one is the high speed of response. So we have already lost seen in the before slide that it can take 500 readings in a minute. So that is a very high measurement. Next, it has versatile in design. So it is versatile in design, and it has easy integration into an automated or integrated system. So it has an automated integrated system. So it will easily integrates the functionality of that one. So these are the different advantages of the electronic comparator. So let's see the working of the electronic comparator. So this is the WHEATSTONE wedge used in the working principle of the electrical comparator. So it consists of 4 resistors, 2 on each arm. So it gets 2 arms, so in which it gets 2 each on one arm, which is balanced when the ratios of it is held. So this is the for the movement in the plunger inserts the pair of coils. So this is seen in the pair of coils. So we have already seen this. So this is the Wheatstone gauge which we are used. So it can be changes from temperature and some other humidity points. So it has 2 volts in one end and 1 volt at the other end, that is the positive end. So this voltage is taken as the width or the input. So amperes has comparators have low propagation delay and fast rise and fall time. So these have rise and fall time. It has very high fast and rise time. So the voltage is taken as Vz in the positive one, and in the negative one it is negatively set. So the waves has been propagated like this, and in general these waves has been propagated like this one, which has a linear measurement. And now we can see the working of this pneumatic comparator. So air compressed is taken for the compressed air, and this is sent to the air filter. So after the air filter, it is then sent to the dip tube and then to the orifice. And then it is sent to the measuring jet. So the air filter sends the filtered air to the measuring jets and then to the orifice. So the gauging head beads have been seen in the picture also. So that is the flexibility with the compared to the manometer, and then the measuring head is measured in this linear movement. So by this, I am ending this class. Thank you.